Welcome to this tutorial. I would be solving question number 10 of paper 2-1 October-November exam series of 2018. This question is related to radioactivity, and there would be some parts related to fission also, nuclear fission. The question says two neutral atoms are atoms of different isotopes of the same element. State one similarity in the structure of these two atoms. So we know that when two atoms are isotopes of the same element, they can always contain the same number of protons or electrons but different number of protons. So I'm writing here they have same number of protons or electrons. Second part says one difference between the structures of these two atoms. So they have different number of neutrons. That is why the mass number is different for isotope, but the proton number is always same. The isotope plutonium-239 decays by the emission of an alpha particle whose symbol is alpha to an isotope of uranium, symbol U. The half-life for this decay is 2.4 10 raised to 4 years. Complete the equation for this decay. So we would start with writing the mass number of alpha particle, which is 4, and the proton number for alpha particle is 2. Now we subtract this 4 from 239, we get 235 over here, and then we subtract 2 from 94. So we get the number 92 as the proton number for uranium. The next part says the count rate measured due to a pure sample of plutonium-239 is 6400 counts per second. So this is the initial count rate. Calculate the count rate after a period of 1.2 10 raised to 5 years has elapsed. So after this much time, what would be the count rate? That is what we need to find out. Now, previously we were given that the half-life for the decay of plutonium is 2.4 into 10 raised to 4 years. If we take this value 1.2 10 raised to 5 and we divide it by 2.4 into 10 raised to 4, then this should give us number of half-lives which are being elapsed over here, and the answer from this division comes out to be 5. So it means that there are 5 half-lives which are involved in this much time which is given to us. So initially the count rate is 6400 counts per second. If 5 half-lives pass, so this should get divided by 2 raised to 5. So 6400 divided by 32 gives us a count rate of 200 counts per second. So this would be the count rate after 1.2 into 10 raised to 5 years time. So the final answer I'm writing over here 200 counts per second. In the next part, the question says figure 10.1 shows an alpha particle entering a uniform magnetic field. Magnetic field is out of the page, so I'm making this symbol which shows a magnetic field is out of the page, and alpha particle is moving to the right, which is also the direction of the conventional current. So the conventional current is to the right in this case, and we have to find what would be the deflection shown by the alpha particle, and we also have to draw the path of alpha particle in this magnetic field. Since we know that when a charge is moving, there is a magnetic field associated with the charge, and when that moving charge is placed in a magnetic field, in another magnetic field, both magnetic fields interact with each other and a force acts on the charge. So for this we would be using Fleming left hand rule to find what is the direction of the force experienced by the charge. So the first finger would be aligned with the magnetic field which is out of the page. The second finger would be aligned with the current which is to the right. The conventional current's direction is same as the alpha particle's direction, and the thumb is pointing in this case downwards. So we get the force acting on the charge in the downward direction. This would be the direction of the force. This is the direction of the conventional current, and out of the page is the direction of the magnetic field over here. So this would be the deflection shown by the alpha particle in the downward direction, and it should be drawn as soon as the particle is entering the magnetic field. The deflection should immediately start and should show a pattern of going downward. Now the second part says explain why the alpha particles follows the path you drew in the previous part. So it is following the path because a force is acting on it, and this is called the motor rule, that moving charge when placed in a magnetic field experiences a force which could be found by Fleming left hand rule. So this is how we can find the direction of the force, and the reason is that the moving charge was placed in a magnetic field. Now the next part says in a nuclear reactor at a power station, plutonium 231 is made to undergo nuclear fission. State what is meant by nuclear fission. So it is a process in which a larger nucleus splits into smaller nuclei, releasing energy. So this is the simple definition of nuclear fission. State what happens to plutonium 239 nucleus in the nuclear reactor to cause fission. So in the nuclear reactor, a neutron is fired at a plutonium nucleus which collides with the nucleus of the plutonium, makes it unstable, and then it breaks into smaller nuclei. So this neutron is initially absorbed by the plutonium, which makes it unstable, and later on it breaks and converts into two smaller nuclei, and a huge amount of energy is also released during the process. State one advantage of generating electricity in a nuclear power station rather than using an oil-fired power station. In case of a nuclear reactor, we don't have emission of greenhouse gases, which is an advantage. Greenhouse gases like CO2 or carbon monoxide. And in the second part, it says an array of wind turbines. So an array of wind turbine requires a larger area where they would be installed. So in case of nuclear power plant, a smaller land or area is required, which is obviously an advantage of using nuclear power plant. So with this part, the question ends here.
We try to explain complex concepts in simple language and with effective examples. If you liked the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.